Good morning, class. We're going to look at section 7.5 today, exponential functions. Exponential functions. Okay, and this is section 7.5. And so let's look at, we're actually only going to have two examples here. It won't take up much room, so feel free to space stuff out. So the first example is 27 to the 3x equals 81. Whoops, equals 81. I'm thinking about exponents here, but there's no exponent on that right-hand side. It's just 81. Now, one thing you should notice, if you've been paying attention to math class, is that 27 and 81 are both multiples of 3. And we're going to use, are both powers of 3. They're 3 to some power. So we're going to use that fact to solve this equation. 27 is 3 to the third power. 81 is 3 to the fourth. You can use your power chart to see if numbers have a common base like that, but by now, if the numbers are less than 100, there aren't really that many numbers that are powers, so you should know what they are by now. Here we need to multiply the exponents. If this was an addition problem, I'd have to distribute, but it's just 3 times 3x is 9x. And one thing that we're going to say now is that if the bases are the same, if the 3's are the same, then the exponents have to be the same as well. So it's like once I get those two bases to be the same, I can just set the exponents equal. And then from there, divide by 9. I'm going to be a little cheap about it there. Okay, I have one more example I'd like to share with you. 15 to the 3x power. Oh, that's it. That's it for that one. It's cool, huh? 15 to the 3x power is equal to 285. So what I'm going to do here is I'm going to take log of both sides of the equation. You might be wondering, why in the world would I do that? Looks like it makes it a little more complicated. Well, what this is going to allow me to do is that when I have a logarithm, the exponent is going to become the coefficient. So I can take this up here and put it out front. And that kind of frees the 3x. Oops, sorry, let me scooch that up there. Okay, so by taking the log of both sides, now I can use that property where the exponent becomes the coefficient. And instead of the x being trapped up in the exponent, now it's out in the open. I can solve for it now pretty straightforward. So let's divide by everything except for the x. So we're going to divide by 3 log 15. Let's do it all at once. It's easier that way. Okay, and so that will cancel out, and that will cancel out, leaving me with just an x. And for this part here, we would need our calculator. I don't have it right here. Go ahead and do it. Here's one. Be sure to put your denominator in an extra set of parentheses and go ahead and punch this in. Make sure you can do it. Okay, so log 285 divided by 3 log 15. You'll need an extra set of parentheses around the denominator because there's more than one thing down there. And you should get 0.6957, blah, blah, blah. The 4 decimals looks great. 0.6958. And those are your notes for section 7.5. You'll probably have to come up with some stuff for the left-hand side.